Good day to all. Today we are all going to discuss about the basics of computer networks. This session mainly aims at dealing about the fundamental concepts of networking, communication model, different network architectures, various components of networks, functions and design strategies of the various layers of networks and various application protocol standards. So what is a computer network? A computer network is nothing but a group of devices that are interconnected to each other to communicate over some communication links. These communication links are going to be called as channels, and the devices which are connected in the computer networks are going to be termed as nodes. So the device in the computer network is usually a computer or a printer or any other device, okay, which are able to send or receive information at each other. So each device in the computer network usually has a unique IP address to get identified in the computer network. The device which is able to send the information to other devices are going to be termed as sender, and the device which are able to receive the information is going to be termed as receiver. So what are the main goals of computer networks? The main important goals of computer networks are to share the information, that is data or application or the hardware resources, and the other important goals are to increase the capacity of the communication medium by adding the new devices or new machines at very less cost, and to increase the reliability and also to provide effective communication medium. So what are the uses of computer networks? Computer networks are used in different application areas. The main important application is in business. They are used to share the information or the resources to other places. In home application, the computer networks are used to access remote information like daily news or information related to cooking, history, health, etc. They are also used to establish interactive entertainment. The best example for this type of application is Facebook as well as WhatsApp that we are using in our day-to-day life. And the person-to-person communication is also possible with the help of text messaging, and Twitter is the best example for this. And you can also do electronic commerce, that is, we can pay the bills online, or we can do the bank transactions online, or we can do online sale or purchase, etc. And the computer networks are also used in mobile applications too. So how the computer networks are laid out? Okay. So a term called topology is used to refer how the computer networks are laid out. So I can say that a topology can be defined as the layout of connected devices in the network. So the topology of the network is usually geometric representation, okay, of the relationship between the communication links which are used to join or which are used to connect the devices in the computer network. So I can define topology as the physical or logical arrangement of the communication links in the network. So based on how the links are interconnected with each other, okay, this topology can be defined as bus topology, ring topology, star topology, tree topology, mesh topology and hybrid topology. Okay. So now let us going to discuss about what are these topologies, right, in detail. So what is bus topology? A bus topology is used to establish multi-point configuration. That is, in this bus topology, one long cable is going to act as a backbone, and it is used to connect all other devices in the network. Okay. So the devices in the computer network are used to be connected to each other through this long cable with the help of these drop lines as well as this type of tapes. Okay. So what are the advantage of this type of cable connection in bus topology is this installation process is very easy in bus topology. Moreover, the redundancy can be easily eliminated, and here this bus topology uses a very less number of cables, okay? But the disadvantage is reconfiguration of the devices connected to each other is very difficult, and moreover the adding or deleting new devices to this network, or adding the new device or deleting the already configured device is very tedious in the case of bus topology. So what is ring topology? Okay, in ring topology, each device in the network has a dedicated point-to-point link between other devices. But here in this ring topology, the signals are passed along this ring only in one direction. So I can say that the communication here is in unidirectional pattern. So each device like A, B, C, D, okay, in this network should have the repeater to send the signals from one device to another device. So the advantages are it's easy to install and faults can easily be rectified in this type of ring topology network. But what are the disadvantages? The traffic is only in one direction, that is, it is having unidirectional traffic. Two-way direction of the data sending is not possible in the case of ring topology. So if one device in this ring fails, okay, the entire network will get failed. So this is the major disadvantage of this ring topology. Then what is star topology? In the star topology, each and every devices like A, B, C, D which are connected to the network are going to be interlinked with each other, okay, through a point-to-point link with the help of a central controller, okay. So the devices cannot be connected directly to each other. They should be connected through this central controller which is called as hub, okay. The advantage is it is very less expensive to construct this type of network, and moreover less number of cables are used, and the star topology network establishes robustness, okay. But the disadvantages are the devices A, B, C, D, okay, as shown in this figure must be connected to the central controller in order to get communicated with each other, okay, and it requires the more installation process, okay. Suppose if the central controller or hub fails, okay, the entire network will be failed. Then what is a tree topology? Tree topology is nothing but it is a small variation of star topology. Here also the nodes, okay, the nodes like A, B, C, D are they are going to be connected to the central controller, and this central controller is going to be called as active hubs, okay. The devices which are directly connected to the central controller are going to be termed as secondary hubs or passive hubs, okay. So the rest of the nodes like C, D, E, F, okay, the additional nodes, okay, can also be connected to this central controller through this passive hubs, okay. So the advantage is we can add any number of devices, that is more number of devices can be connected to this network using this primary hub as well as the secondary hub concept, okay. So moreover it allows the network to give priority to the communication, okay. Then the disadvantages are each device, okay, for example this secondary hub must be connected to the central controller. If the central controller fails, okay, the entire network will get failed also, and moreover it requires more installation process. This is very tedious one, okay. So what is mesh topology? Okay, in mesh topology the devices, okay, every device in the network is having a direct link to every other devices in the network, okay. So a fully connected mesh network, assume that if it is having n number of devices, then there should be n minus 1 by 2 the physical channels or physical links or communication mediums are needed to join all these n devices, okay. For example, if I am connecting 5 different nodes in mesh topology network, then I need 10 different links, okay, to get connected all these devices. So the main advantage is it eliminates traffic problem because each and every device is having a separate path, okay, to communicate to the destination device. So it's offering robustness, it is providing privacy and security, and moreover faults can also be easily found, okay. But the disadvantages are the number of cables, okay. The number of cables is very large in this mesh topology, okay. So every device must be connected to every other device in this network. That means it requires more installation process. one type of topology. Okay, in this I can combine, okay, many topologies like a star, ring or bus topology to make this hybrid topology. So we need to deal about network hardware. Okay, what is network hardware? Each device, okay, each user device which is connected to the computer network is usually termed as host. Okay, the hosts are usually connected by subnets. Okay, these subnets are responsible to carry the messages between the user devices, that is called as host. Okay, so this subnet is usually made up of what? These transmission lines. Okay, transmission lines are the trunks or channels or different circuits, etc. Okay, so the subnet is usually made up of transmission lines as well as switching devices. Okay, switching devices are nothing but some computers which are helping, okay, to intermediate the data from sender to another device through these communication lines in the subnet. Okay, so how the networks are going to be classified? Okay, so the networks are going to be classified based on two terminologies. One is based on transmission technology. Okay, based on how the transmission is going to happen. Okay, the network is going to be classified as point to point as well as multi-point. Okay, then based on scaling, the network is going to be classified as personal area network, local area network, metropolitan area network, wide area network as well as internet. So let us going to discuss about these type of classification in detail. Okay, so based on the transmission technology, that is how the subnet is designed, right? This classification is based on, is divided into two types. One is point to point and the other one is broadcast subnets. So what is point to point? It's nothing but the two devices are directly connected, okay, with the point to point links. Okay, the best example is public switched telephone network, which otherwise be called as PSTN. Okay, suppose if there is no direct link between source as well as the destination device, then the source will send or will route that message to an in-between device which is called as switch. Okay, so this switch, I already told that switch is nothing but it's a computer or any other device. Okay, so this switch will retransmit that message to the destination. Okay, so this type of point-to-point communication is going to be termed as unicasting. So what is unicasting? One sender and is having exactly one receiver. Okay, then broadcast subnets. What is broadcast subnets? In the broadcast subnets, the sender usually sends the message over the network and all the rest of the devices in the network are eligible or having the possibility of receiving that information. Okay, so it is coming under two categories. One is broadcasting and another one is multicasting. What is broadcasting? In terms of broadcasting network, the information sent by the sender, okay, usually received and processed by every other machines on the network. But in the case of multicasting, the information sent by the sender will be received and processed by only the subset of the machines. Okay, so another important terminology, okay, or methodology to classify the network is by scaling. Okay, here distance is going to act as an important metric to classify the network. So based on the distance between the devices which are connected in the networks are going to be classified as personal area network, that is, which is meant for only one person in the network, and longer range network. Okay, longer range network are still broadly classified into LAN, MAN as well as WAN. Okay, let us explain one by one in detail. Okay, so internet is also one type of classification of the network based on the distance. Okay, so in the case of personal area network, the distance between the devices is just 1 meter, around 1 meter. So the processors or machines or devices are going to be located in a particular square meter, in the same square meter itself. In the case of local area network, the devices are going to be connected, okay, in the distance range between 10 kilometer to 10 meter to 1 kilometer. Okay, so the distance between the devices connected in the local area network spans around 10 meters to 1 kilometer, and the devices are located in the same room or either in same building or in the same campus. Okay, in the case of metropolitan area network, the distance between the devices is approximately to 10 kilometers, okay, and the devices are going to be in a particular city, okay. So in the case of wide area network, right, the devices distance, okay, varies from 100 kilometers to 1000 kilometers, right. Usually the devices in a particular country or continent are connected through this wide area network. And we all know that the internet, okay, the internet is spans around the distance of more than 10,000 kilometers, and all devices in this planet can be easily connected to the internet. Okay, so what is local area network? As I told already, local area network is a privately owned network where the devices in the particular room or devices in the particular buildings, okay, or a particular factory or inside a home or inside an office can be connected to each other, okay. So there are two variations in this. One is wireless LAN and next one is wired LAN. In the case of wired LAN, okay, these can send the data at the speed of 100 megabits per second to 1 gigabits per second, and they have only very low delay as well as the errors also very less in this type of network, okay. But we also know that newer LAN can send the data up to 10 gigabits per second, okay. Then many different topologies can be used to lay out this LAN network, okay. The basic topologies which are used to construct this type of LAN is bus based as well as ring based topologies, okay. So here the channel allocation, that is the communication link allocation, may be either static or dynamic, okay. Then in the case of metropolitan area network, okay, it usually lies between local area network as well as a wide area network, okay. It usually covers a particular city, okay, or a particular town, okay. And usually this metropolitan area network is mainly designed for customers who expect high speed communication, high speed data communication. The best example for this metropolitan area network is cable TVs, okay. Right. So this WAN network may be private network or it may be owned by public people. So in such a case, it becomes a public network. This WAN network, it supports both the data communication as well as voice communication. Okay. So usually this metropolitan area network has more than one cables as well as many switching elements. Okay. Right. So the advantages are it offers a high bandwidth and it is able to support n number of clients, okay, and the errors are also very less, okay. But the disadvantages is it needs large space requirements, okay, and moreover we need a high cost to establish this type of network, and moreover the data access also sometimes may be slower. Okay. Then wide area network. We also know that wide area network usually spans around large geographical area like country or continent. Okay, this is coming under two possible categories. So one is switch to WAN and the another one is point to point WAN. In the case of switch to WAN, okay, one device in a particular LAN network can be connected to another device in a particular WAN network, and this needs a router. That is, we are connecting two heterogeneous, that is different types of networks together in case of WAN. So in such a case, in order to get connected to this two types of heterogeneous networks, definitely a particular device called router is needed. Okay. So the point-to-point WAN is nothing but it's usually a line leased from a cable TV operator or from a telephone department. Okay. In order to make my home computer or my own LAN to get connected to wide area network in order to provide internet networks. Okay. So this is possible with the help of internet service providers. Okay. So now I am going to just to share a few points about what is data communication. So what is data communication? It's nothing but exchange of information between the devices which are connected to the computer through some communication channels or links. Okay, these communication channels are going to be termed as communication medium. Okay, usually the data are going to be transmitted in terms of zeros and ones. Okay, so the components, what are the important components of this data communication model? Okay, so this data communication to happen, okay, 5 components are needed. One is sender, the device which is able to send the information. Okay, the receiver, which is used to receive the information sent by the sender. Okay, and then the communication medium. Communication medium is nothing but the physical channel or physical path, okay, which requires to connect both sender as well as the receiver. And the message, okay, message means what information I am going to pass from one device to another device. And the main important component is protocol. Protocols are nothing but a set of rules and regulations which governs the data communication. So what are the important characteristics of communication model? Okay, so four important characteristics are needed, okay, to make this communication a successful one. Okay, so delivery, the system must deliver the data, okay, to the correct destination. And accuracy, the system must, okay, deliver the data in an accurate pattern. And timing, the system must deliver the data in exact time, okay, and jitter, okay, and it refers to about the perfect arrival time of the information. Okay, so while dealing with the data communication model, we need to talk about a transmission mode. What is transmission mode? Transmission mode is nothing but the direction of the information flow, okay, between the two devices in the communication medium. Okay, so the direction of the data flow can be divided into three types. One is simplex, half duplex, and the final one is full duplex. In the case of simplex mode, the data will be traveling in only one direction, that is either sender can send the message, okay, and receiver can receive the message. The best example is radio and television networks, broadcast networks. Okay, then half duplex. Okay, in this case both sender and receiver are able to transmit, but only at one time. Okay, so the direction, only one direction, the data will be sent at a particular time. Okay, either the sender has to send, okay, the receiver must receive. After the completion of the sending of information by the sender, then only the receiver can be able to send the information back to the sender. Okay, so usually the conversation on walkie-talkies, okay, coming under this transmission mode, half duplex. Okay, then what is full duplex? Here the data transmission will be in both the directions. The best examples are, we all know that phone conversation, okay, telephonic conversations are the best example of full duplex mode transmission modes. Okay, right. So in order to make this network to properly work, okay, network softwares are needed. Okay, so what is the network software? So network softwares are a highly structured one which are organized, okay, in terms of layers, okay, in terms of layers or levels. Okay, what is the purpose of arranging this network software in layers? Or in order to reduce the complexity of the designing of this network. So usually network software is a highly structured one which are comprising of many layers or levels. Oh, right. So usually the number of layers in the network, the name of that layer, the content of that layer, the functions of that layer is different from network to network. Okay. So while talking about the network software, we must know about a protocol hierarchy. Okay, what is a protocol? Protocol is nothing but, I already told you, it's a set of rules and regulations that govern data communication. I can say that a protocol is an agreement, okay, between the communicating parties on how this communication must be proceeded. Okay, so the process is comprising of different layers, okay, on different machines, right? The layers are the same layers on different machines are going to be called as peers. Okay, so the peers can be processors, hardware devices, or even some computer beings also. Okay, so usually one device is going to send the data to another device. Okay, but the network software is arranged in. Okay, so the lower layer is going to send the information or provide the services to the higher layers. Okay, like that each and every layer is providing its service to the higher layers. Okay, thus transmitting the information or providing the service to the other layers in other machines also. Okay, so no two layers in different machines are not able to communicate with each other directly. Instead, okay, they are communicating through the layers which are below that particular layer. The information is passed, okay, and finally it reaches to the lowest level, and the information is carried through the communication path, that is physical path, and from there the physical path sends that information to the higher layers which are residing in the next mission, that is the destination mission. Okay. So interfaces. Okay. So as I told already, the function of each layer is to provide services to the other layers which are above it. Okay. So the active elements in each and every layer is going to be called as entities. Okay. So the entity in the layer n is going to be called as service provider, and the layer n plus 1 is going to access that service and is going to be called as service user. Okay. The layers, okay, are offering two types of services. One is connection oriented and the next one is connectionless service. Okay. What is connection oriented service? In order to make the communication between two devices, a permanent connection is needed. Okay, must be established. Okay. So in the case of connectionless service, the permanent connection is not needed. Okay. The sender can send the message and he can wind up the connection. Okay. And when the receiver wants to receive that information, at that time it can connect to that network and receives that information. Okay. So the connection oriented service is usually managed by a protocol called Transmission Control Protocol, which is otherwise shortly termed as TCP. And in the case of connectionless service, this UDP protocol, that is called as User Data Transfer Protocol, is being used. Okay. So now let us going to discuss about protocol in detail. I told that protocol is a set of rules that govern data communication. It is comprising of three main important components. Okay, three important key elements which are termed as syntax, semantics, and timing. What is syntax? Syntax refers to the structure of the data, okay, to be transmitted. And what is semantics? Semantics are nothing but the meaning of each bit in that data. Okay. Then what is timing? The timing is nothing but when the data sent. It refers to when the data sent and how fastly it is sent. Okay. So the protocols are usually coming under two categories. One is de facto standard and another one is de jure standard. Okay. In de facto standard, it is coming into two categories. One is proprietary and another one is non-proprietary. Proprietary means it's owned by a particular company, and non-proprietary means it's not owned by any people. And it is generally widespread, it's used widespread, but it's not officially adopted. But the de jure standard, okay, it is a standard legislated and adopted by the official people. Okay, so the official standard organizations which adopted this de jure standards are International Standards Organization as well as ANSI. Okay. So whenever I am talking about the different layers of the computer network software, I need to talk about service primitives. What is primitives? Primitives are nothing but it's operations. Okay. So a service in the computer network usually consists of many different primitives or operations like listening, connecting, accept, receive, send, and disconnect. Okay. So how the networks are going to be framed? Okay, so the networks are going to be framed based on some reference models. Okay, so the very important models are OSI reference model and TCP/IP reference model. Okay, so what is OSI? OSI is nothing but Open Systems Interconnect. Okay, here it is a model, okay, which allows any two devices in the computer network to communicate, okay, regardless of the underlying architecture or the software. Okay, so usually it is comprising of many different layers. It's comprising of 7 layers. Okay, from the top layer, I am just listing down the layers. Okay, from the top layer, application layer, and then presentation layer is located below that application layer, and then session layer and transport layer, and in the lower layers network layer, data link layer, as well as physical layer. Okay, so the information is going to be sent from the application layer to presentation and session and transport, and it is passed up to this physical layer. This physical layer is sending that raw data to the communication line, and once again it reaches the physical layer of the peer layer, which is in the other part of the receiving machine. Okay, that physical layer is responsible for moving that information to data link, network, and finally to this application layer. In this way, the data are going to be sent through this layered concept. Okay, so this OSI reference model usually tells what each layer must do. Okay. So this is the diagram, exact diagram of how this OSI reference model is being presented. Okay. Usually this dotted lines are referring to the virtual communication between this. Actually, there is no direct communication between this session layer of one device to session layer of another device. But this session layer of this device can communicate, okay, through the lower layers and through this physical path which is shown in the fully solid line, okay. Through this lower layers like physical and then the upper layer and then the further upper layer network and then further layer transport layer and finally to the session layer. So what is the function of physical layer? Okay, the physical layers are usually responsible for the raw representing the message in terms of raw bits of data, that is called as zeros and ones. Okay, so the transmitted bits usually encoded into electrical signal or optical signal. Okay, so this electrical signal or optical signal will be passed to the physical path. Okay, so the physical layer usually determines or defines the transmission rate of the computer networks. Okay. Right, so it follows the line configurations, okay, like point to point or multi-point, or it uses the ring topology or star topology to get connected, and it uses different transmission modes like simplex, half duplex or full duplex. Okay, then what is data link layer? The main important responsibilities of data link layers are framing. So what is framing? The stream of bits are going to be combined in terms of frames, and each frames are going to be added with some header address, and these header address is going to be called as physical addressing scheme. Okay, then this data link layer is also responsible for flow control as well as error control. What is flow control? Suppose if the data rate at which the receiver is receiving is not matching with the sending speed of the sender, okay, then the communication is somewhat meshy. Okay, in order to take care of this situation, these flow control mechanisms are used. Okay, then what is error control? Okay, whenever I am sending the data, some of the data may be lost. Okay, so this network must provide some mechanism to recover that lost frames or lost data. Okay. Similarly, access control. When two or more devices want to connect to the same communication channel, okay, to whom that communication channel should be allocated, that is going to be dealt by this data link layer through access control mechanism. So many protocols are used for this data link layer to control this access mechanism. Okay, then what is network layer? So the network layer is usually responsible for source to destination transmission. Okay, in this layer, the frames are going to be combined, are going to be managed as converted into packets. Okay, so these packets are going to be transmitted through network layer. Okay, so now my network layer is going to find a particular route. Okay, this is going to be called as routing. So all the routing algorithms are going to be residing in this network layer. Then what is transport layer? Okay, this transport layer is responsible for process to process or end-to-end delivery of the entire message. Usually, the network layer usually sends packets, okay, to the right computer, okay, but the transport layer is responsible to send that entire message to the right process which are operating on that particular computer. Okay. So what are the different transport layer functions? Okay, the transport layer is used for providing the useful functionalities called segmentation. Okay, so the original message is going to be segmented into small chunks. Okay, so these small chunks are going to be transmitted. Okay, and at other end they should be collected, and once again it has to be rearranged and has to be joined again. Okay, so this process is going to be done by this transport layer. So the segmentation and assembling and disassembling the packets or data is very important in transport layer. Moreover, it is providing the connection control services in terms of connectionless as well as connection oriented service. Okay, then what are the important functionalities of session layer? Okay, the session layer is responsible for dialogue control as well as synchronization. Okay, for example, the dialogue control, whether the communication has to happen between two devices at the same time, or whether one device is able to send and the other device must listen. Okay, that will be decided by this session layer in terms of this half duplex as well as full duplex mode. and it is offering one more important service called synchronization. Okay, synchronization is nothing but adding checkpoints, okay, at different places in the stream of data. For example, I am going to send some 10,000 bits of data at a particular time. Okay, now I am going to insert a checkpoint at each 100 bits page. Okay, so suppose if right one page fails, in case of failure, I need not send the entire data again. Okay. So what is application layer? So the application layer is responsible for providing the services to the user. Okay, this application layer is running many different processes like remote login, file transfer protocols, okay, as well as directory services, message handling services, etc. Through different type of services, it is providing the service to the user using the lower layers of the network. Okay. Okay. So, whenever talking about computer networks, one must talk about the physical path, okay, which lies between the devices which are connected in the network. Okay. So, this physical path which are connecting two devices in the computer network are going to be termed as transmission medium, okay, or communication medium. Okay. So, the transmission media is nothing but it's a physical path between transmitter as well as receiver. Okay. Usually the amplifiers, a device called amplifiers or repeaters are needed, okay, to increase the length of this physical path. Okay. So this data transmission channel or transmission media is going to be divided into two types. One is guided channel, guided medium, and another one is unguided channel. What is guided channel? In the guided channel, there is a physical path, okay, laid in between both the transmitter as well as the receiver device. Okay, the guided medias are of different types. Okay, I can connect two devices with the help of either twisted pair cables or coaxial cables or optical fibers. Okay, in case of unguided channels, okay, there is no physical path. There is no physical path between both the transmitter as well as the receiver. Then how the communication is going to happen is how the data is going to be transmitted from the sender as well as the receiver. So here radio waves, microwaves and infrared signals, they are going to be used to transmit the signals from one place to another place. Okay. Now I am going to just show what each these guided media as well as these unguided medias are. Okay. So the twisted pair cable. Okay. We are seeing this twisted pair cable in our day-to-day life. Okay. So these cables are very cheaper and they are lightweight and they can be easily installed. Okay, so it is usually a pair of wires which are insulated by a plastic sheet. Okay, and these cables are twisted together. That's why they are going to be termed as twisted pair cables. Okay, so the advantages are they are very easy to install and they are flexible and they can cover up to 10 meters. Okay, but the disadvantages are they are very less bandwidth. Okay, it can pass very less number of bits from one place to another place. Okay. Then this is unshielded twisted pair cable. Okay. So this unshielded twisted pair cable is mainly used in telecommunication devices. Okay. Then one more term is coaxial cables. Actually, these coaxial cables are mainly used for cable TV. That is, in case of metropolitan area networks, this type of cables are mainly used. Okay. So copper is used in this medium, okay, as a central conductor and which can be surrounded by this shielded materials, okay, as shown in the picture. So this is the picture of this coaxial cable, and we can also use optical fiber. Okay, so in the optical fiber a particular technology is used, okay, to transmit the light signals through glass wires. Okay, so what is the big advantage is the speed of light is very large, as we know. Okay, so here the data are going to be transmitted at very fast. Okay, and moreover there is no errors, there is no loss of data in case of this optical data. Then what is unguided media? Okay, so as I told already, unguided media is used for transmitting the signal without any physical media. Okay, so usually it transports the electromagnetic waves. Okay, and it is going to be primarily called as wireless communication, and we are the victims of the wireless communication in our day-to-day life. Okay, so the signals are usually broadcasted through air and it's going to be received by either one device or n number of devices. So what are the different types of ways we are using, okay, to send the information in case of this unguided medias are radio waves, okay. Like these radio waves, okay, are easily generated, can be easily generated and can travel over a long distance and can penetrate the buildings easily, okay. So it is very much used in this wireless communication. So in the case of microwave transmission, okay, these microwaves are going to be traveled in straight lines, okay. So therefore they are narrowly focused, okay, concentrating all the energy into a beam, okay. But periodic repeaters, okay, so repeaters are needed, okay, to send the signal once again from this place to another place, or to cover long distance, okay. But the main disadvantage of these microwave transmissions are they are not able to penetrate through buildings. So within a building, I can send the information from one place to another place to this microwave. So in order to transmit or receive the signals, I need some antennas, okay. The antennas, and moreover the antennas must be aligned properly to receive the signals. Okay, so satellite communication, okay. So this satellite communication we already know, okay. The satellites are usually launched either by the rockets or space shuttles, okay, in space, okay. So these satellites are going to transmit the signals, okay, and the signals transmitted by these earth stations are going to be received, these satellites are going to be amplified and going to be retransmitted through the other receiving stations or ground stations in the earth by this satellite communication, okay. Usually they are used to cover a large distance, for example approximately at about 3006 kilometer distance, okay, within an equator around the orbit in our planet, okay. But the satellite manufacturing, some problems which are occurring in this satellite communications are the cost is very high to construct these satellites. Moreover, the launching satellite is also a very expensive one, okay. Moreover, it depends on the typical weather conditions, okay. Sometimes the satellite communication may go failure, okay, due to some bad weather condition, okay. Right. So, infrared rays. What about infrared rays? Infrared rays cannot be used for long range communication because it is not able to penetrate walls. So, it is able to send information through some short distance devices. Okay, right. So, usually the remotes we are using at our home, okay, to change the signals of our TV, okay, use this infrared signals, okay. So these are some of the terms we studied in unguided media. So now let us just give a gist of what we have discussed in today's session, okay. So we discussed about what is a computer network, what are the applications of computer networks, where we are using the computer network, what are the different goals, what are the components of computer network, how the networks are laid out, okay. The networks are laid out with the help of topology, and what are the different types of topologies, tree topology, mesh topology, bus, ring, hybrid topologies, okay, and what type of network softwares we are using, okay. In order to construct that, the network softwares are usually arranged in terms of layers, okay. Each layers are responsible for providing services to the higher level layers, okay. So how these layers are going to be constructed, okay. So some reference models have been stated and adopted, okay, along with the protocols, okay. So both the reference model, the models as well as the protocol standards, they are going to be termed as network architecture, okay. So suppose if a person want to build a network, then he has to follow a particular reference model and must follow the protocols, that is the rules and regulations which are defined by those reference models. Based on that, they should construct the network in order to make the communication an effective one. Thank you.